Hello, and thank you for taking the time to view this recorded webinar on Thermiser Max Insulated Rolling Doors. We'd like to introduce Thermiser Max as the only coiling door design that's compliant with the International Energy Conservation Code 2012, also called IECC, air infiltration requirements for rolling doors. In the past, rolling doors were exempted from the IECC code, and an exemption was able to be taken on rolling doors. That is no longer the case. With the implementation of 2012, the IECC is now requiring that all rolling doors put on a building that has conditioned space meet the air infiltration requirements that are prescribed in the code. So what is everyone talking about? As you take this product to market, you'll be involved in conversations regarding energy efficiency and savings and the different components that comprise that. So let me take you through a few terms that are common vernacular in that area. You'll find these in the quick guide that were distributed as part of the rollout package when we introduced the product, so there's no need to take notes. You'll find all that information on the DRC. First of all, air infiltration, air leakage, infiltration rate are all pretty synonymous and are very important when looking at the energy efficiency of a building. Air infiltration or air leakage is the quickest way to exchange heat or cold through the building envelope and reduce the energy efficiency of the building. As we mentioned before, conditioned space is a key component, whether that's heating or air conditioning. The IECC code is required for any building that has conditioned space. So when you're looking at a project that will have either heating or air conditioning within either individual compartments or in the building as a whole, you need to look at the air infiltration requirements as prescribed by the IECC. Now, conduction versus convection, you might have heard these before. Conduction is essentially the movement or thermal transfer through a substance. Think of it like conducting electricity, how electricity moves better through some things like copper than it does through others. So you can conduct heat or cold through a substance either faster or slower. Of course, the faster it is, the less efficient it is. And the same is true with convection, although convection is more the thermal transference through gases like air. An example of that would be your convection oven, where it's forcing the heat through the air of the oven to cook your food. So you need to look at both conduction, which is more insulation, and convection, which is more the transfer through the air into the heated or conditioned space. Now, insulation, thermal resistance, R value, it's something we're very familiar with. Of course, R value is just the thermal transfer or the resistance of energy through a homogeneous substance. You could have an R value of 6,000, which is completely ridiculous, but if that is hanging in an open area, such as in a doorway, the R value doesn't make any difference if your air infiltration is such that you are losing a lot of your energy efficiency or gaining heat through convection in the opening. So R value, although it's a common term, it's not absolute, and it can't be looked at in isolation. It needs to be looked at as part of the entire system. Now, thermal transference or thermal transmittance, that's the rate of transfer of heat through a structure pretty much divided by the difference in temperature across the structure. Simply put, it's how much heat gain or temperature loss you lose through your building envelope. Now, a thermal break can assist in preventing that, and thermal break can mean a lot of different things. Especially for those of you who are familiar with sectional doors, thermal break is usually used as a separate material that would be between two types or two kinds of a similar material. Like breaking the panel into two pieces. It can also be meant as a way just to stop the flow or thermal transfer of energy. There are a lot of different terminologies or definitions. There's even one that calls it an obstacle to flight. It's a heat barrier. So when you have an element of low thermal conductivity placed into an assembly that blocks the conductivity, that is also a thermal break. So it doesn't need to be between two things. It just needs to be between two areas of temperature, and it separates those two from each other. Now, U factor versus U value versus R value. There's a lot of terms you can throw around and most likely put your customer to sleep with. But in very basic terms, the U value is a calculated value based on the inverse of the R value. So if you have an R value and divide that into 1, the decimal value that you get would be your U value. Now the U factor is actually a it's a tested value of the heat transfer via conduction and radiation through an entire system. So it's a much better measure to use when looking at the overall efficiency of a system or the building envelope. Again, if you were to just look at R value in isolation, it would not mean a lot. If you just look at the U value, which is a calculated value of the R value in isolation, it would not mean a lot. The best thing to use is the U factor, which takes into consideration the insulation or R value, the air infiltration, the conduction and convection of the entire system. It's a much better term. Unfortunately, some systems, some valuation systems require a U value be entered, even though it is just a calculated value. So we talked about IECC. Let's talk about where it's being adopted right now and whether or not that matters. If you look at the kind of peach-colored and yellow-colored areas, those are the states that either have currently adopted IECC statewide or in the process of doing so. The remaining colored states are states that utilize some type of ASHRAE 90.1. Now, it's important to recognize that ASHRAE 90.1 is currently adopting the IECC regulations, so the requirements that are in IECC will be pretty much spread across the country in all states very soon. And even if it's not at this point or in the future, it's still a key selling point and of big interest to architects around the country. For instance, I had an architect in Kansas City contact me regarding a project in Oklahoma where she was inquiring as to whether or not our products met the IECC previous. I told her there was good news and better news. The good news is that the products are exempted for now. The better news is that we have product that would be compliant in the near future. At that point, she said, great, I'm going to use it on this project. I'm going to put it in my master spec for a project I'm doing in Colorado. Truth and honesty, I told her that those states did not require it, and she said that didn't matter. She was more interested in doing the best thing for her client and making sure that they were providing the most energy efficient structure possible. So even though she was in a state that didn't require the air infiltration requirements and was working on projects in 2 other states that were the same, it was very important for her to know and use a product that was compliant and provided the best sealing possible. Another situation, we had this product on display at Greenbuild, and we had a national account walk right past me before I could even describe the product. Saw the description and said, we need to have this. Before we could get home, they researched our contact information in the show brochure and had actually contacted us asking an audience for us to come in and present the product to them. So this is quite a hot button. For those of you that are in states where it is actually required by code, it's a no-brainer. For those of you who are in the other states, it's a very easy sell. very quickly adopted. So where do the conventional doors fail? As illustrated here, you can see in the top diagram, you can get a lot of flow through the curtain itself, especially if it's not insulated, around the curtain through the guides, and then the guide material itself, where you can see the little blue arrows radiating inside the building, indicating you're letting cold air or you're having heat gain pass through the guides into the building itself. Down below, up at the header assembly, hood baffles, not too bad, but not the best thing going. So most doors, if they try to seal up the hood, they're going to use a hood baffle and maybe a brush seal, but they don't really reduce the rate of air infiltration to acceptable levels. What you now have is an independently tested and exclusive design. It's based on our current Thermiser insulated door curtain and construction. We've minimized the tolerances, tightened up the construction of the product, and we've included a sealing system that we currently have a patent pending on. And that's comprised of a couple things. First of all, we seal up at the lintel. We have a exclusive modified blade and brush seal combination that utilizes our Z or L mounting extrusion up at the lintel, and the blade portion of the seal actually contacts the curtain to give you a nice positive closure at the top of the door. The size of the seal itself will vary. It'll project out based on the door width and the amount of deflection expected at the barrel. In addition to that, we have thermally broken guides. And these are foam blocks that are inserted between the wall and inner angle, either on Z or E guides. And the size of the blocks themselves will vary based on the pack-off. They come in either 3 3/8 or 4 1/4 inch, and that addresses the vast majority of our pack-off situations. Now, to apply the seals, it's just a matter of compressing the foam block into the guide. There are no fasteners, no adhesive. You don't have to caulk these. They stay within the guide. They're black in color, and they have a good appearance. They're also very durable closed cell construction, so they're weather and UV resistant, so they can survive extreme conditions, whether it's snow, heat, moisture, anything that might be thrown at them. They're very durable. Now, between jam construction is also available, but to ensure that we have the right sealing and dimensions for the product, you'll need to consult the factory for that. Now, the key benefits that these modifications provide are as follows. Of course, we meet the 2012 IECC air infiltration requirements. The requirement itself is 1.0 CFM per square foot, and we are the only coiling door design that meets that requirement. The exclusive sealing system that is patent pending that we just talked about includes the lintel seal, the thermally broken guide construction, and the insulated curtain. Combined, they minimize air infiltration and thermal transfer and provide maximized energy savings to the building owner. A very compelling figure is that by using this system, you can decrease air infiltration versus standard products by 85%. It's kind of jaw-dropping when you think about it, just how much you can close down the opening. Plus, just like the standard Thermiser, you can reduce sound transmission by 37% as compared to non-insulated rolling doors. And it's not just talk. We have the results to back them up. The air infiltration rate that we were tested at is 0.66 CFM. As I said before, the requirement is 1.0, so we almost cut that in half with our system. The R value is consistent with the current Thermiser at an R value of 8, and the U value is 0.125. Again, that's the calculated rate of heat transfer, but that's important to know if you're using programs like ComCheck to input the efficiency of the system. And also, just like the Thermiser, as I said before, the SDC is 27, and that's a tested assembly per ASTM E90. Now, what does it provide to the customer? Here, the large charts on the left show a Thermiser Max compared to a standard insulated door. Very quickly, you can see that depending on the zone you're in, you're looking at an annual savings of anywhere up to $413 per year, which would pay back the upgrade to a Thermiser Max in about 1 year. And of course, our doors go on forever, so that annual savings will just continue to accrue over year over year. If you look at the Thermiser Max 24-24 gauge door as compared to a standard service door, non-insulated, the savings are much more dramatic. In Zone 1, your savings are just shy of $1,000 per year. And these numbers are based on a 12 by 12 door. Of course, as the door gets bigger, the savings increase more dramatically. Now, if you look at savings like that, of course, it costs a little bit more to upgrade to the door, so the payback period is a little bit longer. But still, you're looking at anywhere from 4 to 2 years to pay for the upgrade, and you're looking at say about 3 to 5 years for the door to pay for itself as you accrue those savings. So very dramatic savings, and I'll show you a little bit later how your customer can look at the savings that they would or have generated for the door size that's specific to their project. Now, to prove all this, for every Thermiser Max that we send out to the marketplace, we're actually going to put this label on the bottom bar. I would build this into your specifications so that your customers are ensured of getting the product that they want, and that your competition is not saying, "Oh yeah, I have a lentil seal and I can put on blade seals, and we'll have your doors operating in a compliant manner." That's not the case. So just like a UL label, make sure they look for the IECC compliant label at closeout. Now, all kinds of applications exist for this product, many of which we've talked about before. Of course, it is required by the IECC code. It's important for any conditioned space where you're looking to save those heating or cooling costs. And it can also provide sound attenuation. All this results in employee comfort, but there's other things you can use it for. You can use it for quality control to control the amount of particulates. You can use it if you have a lot of infestation and you want to make sure you're sealing the opening as much as possible. And it's not just for interior openings. Even though it's minimizing air infiltration and thermal transference, you can use it at any opening where you're looking to separate environments. Again, you might have manufacturing on one side and assembly on the other, and you want sound attenuation, and you want to reduce the amount of vapors or smoke coming from one side to where the majority of your employees are. You could have a high-tech manufacturing facility where you want to make sure that the electrical components are free from dust or any particulates that might be transferred from one internal area to the next. So don't just think of this as a building envelope solution. Think of it as a total building solution, and you can find a lot of different areas where a very low CFM is desirable. To help you promote this, of course, as I said at the beginning of the presentation, there's a quick guide that has all these fun facts and figures in it, so you don't need to remember them all the time. You can always go back and refer to the sheet to again, go back to the facts and figures, go to the glossary, familiarize yourself with the terms, and become an expert on the product, or refresh yourself just before going on a call. For presentation to your customers, of course, we have new data sheets. They utilize a new format that we're going to be using for Cornell going forward. As you can see, it's nice, clean, and green, and it has all the pertinent information included. Now, the savings calculator that I talked about previously is on the public side of the website. The customers can go in, they can select whether they want to evaluate the Thermiser Max to a standard service door or a standard insulated door. indicate their opening width and opening height, and receive a calculation of the savings that they would incur. As you can see on the right, that's the output that they would look at. And for this example, I used a 20 by 20 Thermiser Max, and you can see how the energy savings are much more dramatic. In Zone 1, you're looking at energy savings of just under $2,700 per year when going from a standard service door to Thermiser Max. Again, very compelling numbers, a very real reason for your customers to upgrade either from a standard service door or a standard insulated door. Of course, we have specifications and RFIs available for you to affect that upgrade, we also have the test reports available to back that up. Additionally, we have BIM objects and drawing generators on the website for you. Obviously, as you're listening to this webinar, we have the recorded webinars online, and we also have an infographic video. Unfortunately, GoToWebinar doesn't allow me to play it within the presentation, but if you go to the website or if you go to YouTube, you can pull up our video, and walking through it, it does a great job of talking about the energy efficiency, the code compliant, the amount of savings that your customers can incur, the durability and flexibility of the product, also the fact that LEED credits are available, and the overall sustainability of the Thermiser Max. A lot of great information, a lot of key benefits and advantages, all told in about 2 minutes. So if you haven't had a chance to check this out, I strongly encourage you to give it a spin, and then whenever possible, direct your customers to the video. Now, we've talked a lot about new construction, but this is not just for new doors. You can retrofit existing Cornell thermisers to meet the IECC 2012 compliance standards. And you can also decrease energy loss and provide increased savings to your building owners that have non-Cornell insulated and service doors. To seal up those profits, all you need to do is fill out the field assessment form that's found on the DRC and provide that information to the service department, and they'll be able to configure your retrofit kits. Important to note, even though we are bringing up the current thermisers up to the IECC standards, we are not providing labels at this time when they are retrofit with the seals, just because you don't really know the condition of the door at the time the retrofit kits are being applied. So you fill out the form, you provide it to the service department, and if it's a Cornell product, you'll be provided guide seals at about $15 per foot of door height, and a new lintel seal to fit the existing extrusion at $7 per foot of width. If it's a non-Cornell manufacturer's product, then what we would provide are the guide and lintel seals as priced above, and then the lintel extrusion, either Z or L shape at $7 per foot of width. And we also need to make sure at that time that there's a bottom bar astrogol or sensing edge or some type of bottom seal to make sure that you're fully sealing up the perimeter. It's a great opportunity for a broad-based service approach. So what we're also offering are air infiltration parts packages that have a selection of the different foam blocks and lintel seals and extrusion, as well as some additional caulking or silicone sealant for the lintel extrusion, so that you can always have these on hand and go out and take advantage of all the retrofit opportunities that are available. Now, when you're ready to order, if it's a new door, what you do is enter it as you would enter a thermiser, and then include the no charge option 9650. That's Thermiser Max IECC 2012 compliant construction, and that'll trigger tag-along options, the three that are listed here. One that'll get you your guide insulation, one that'll get your lintel seal modification, and also a note indicating the pass doors, exhaust ports, the types of things that would create additional air leakage are not compatible with the Thermiser Max construction. Now if you're looking to retrofit, as I just said, all you do is complete the field assessment form and then contact customer service, and they'll be happy to provide you the components that you need. Now while you're out there selling this product, you might run into a competitor's product, the Overhead 627 Storm-Tight Door. I want to take you through this a little bit just to let you know that it's very easily overcome or very easily removed from the specifications. So what is it? It's basically an insulated door, and their claim to fame is that they've got an R value of 10.9. Now, of course, the way to increase your R value is to create or increase the amount of the homogeneous substance so that you get a better insulation value just for that one component. Again, the R value in isolation doesn't really mean that much. So to achieve that, they had to thicken up their slat. But when you fatten up the slat, it also creates some other issues. Now, if you look at the coil area of Overhead 627 versus the Thermiser Max, the overall area is almost double because you have a fatter slat and increased coil size. So that creates some overhead clearance concerns. Because of the additional weight of the slat and insulating material, their standard height is reduced to 19 feet, where the Thermiser Max can go to 30 feet. And they only claim a 20,000 cycle spring life, probably because of the additional load that's being put on it by the increased weight of the curtain. And of course, the Thermiser Max is rated for 50,000 cycles, so more than double. More importantly, though, it lacks the air infiltration capabilities of Thermiser Max. There is no CFM per square foot data and no IECC 2012 compliance. Now, as if this wasn't enough, the bottom line is the bottom line, and the pricing is approximately 15% higher than Thermiser Max. So there's a lot of ways to go at this, whether it's the clearances, the reduced dimensional capabilities, or more importantly, the low air infiltration capabilities. All the facts and figures for this are again located in your quick guide. You'll see that at the very end. We also have a bunch of materials on the DRC to help you substitute the Thermiser Max in place of or as a better equal, if that's such a term, to the Overhead 627. But what I really want you to remember is that IECC looks at air leakage as its requirement because that's the key driver of energy loss. You can have R value, but in isolation it doesn't mean anything. It's really how much the air or temperature can travel through the air into the building. The R values, the U values, which is the calculated inverse, are insignificant if the door does not prevent air infiltration. And in case you forgot, Thermiser Max is the only coiling door design that is compliant with the new 2012 IECC air infiltration requirements. So, start profiting from this proprietary position today. You've got a unique product that provides substantial energy savings to your customers with a patent-pending system that no one else can match at this time. So tap into your arsenal of sales support, go to the DRC, become familiar with all the RFI, substitution packages, things that you have for the Thermiser Max, view the video, direct your customers to it, and start taking advantage of all the opportunities on new construction projects and in existing facilities where you can really provide your customers with increased energy savings and better performance for their buildings. Again, thank you for taking the time to view this webinar on Thermiser Max, and if you have any questions, please do not hesitate to contact your regional manager or inside SSR. Thanks again for taking the time.